So, for example, let's say we have unpolarized light, so that means it's oriented in all the different directions. Let's say it falls on a filter whose axis is vertical, and after that filter we have a second filter whose axis is 30 degrees from vertical. Let's find out what percentage of the original light we end up with after the light has passed through both filters. So we'll just call this original light some I naught. So some original I naught. We're going to find what percent of I naught makes it through. Now this equation here, this equation is only applicable with polarized light falling on a filter. This equation isn't applicable if light is unpolarized. But conveniently enough, if our light is unpolarized, we will always lose half of it. So the intensity of our light after the first filter is already half of what it originally was. How is it oriented? Same as the filter. So our light is now polarized, and it's polarized in the same direction as the filter itself. So now this equation will apply because we have polarized light that's shining on this second filter. So the intensity 2, the intensity of the light that makes it through, is going to equal the original intensity shining on the filter. I naught represents whatever intensity shining on the filter. So what intensity do we have shining on this filter? The 1/2 of the original. So 1/2 I naught. And then we have the cosine squared. The angle between our light and the filter is 30 degrees. So the cosine of 30, we want to square that and times it by 1/2. Is that really right? Nope. Maybe I'm in the wrong mode. Yes, I am. That's why it doesn't make sense. So cosine of 30 is the square root of 3 over 2. Square that and multiply by 0.5. We get 0.375 I naught. So after passing through those two filters, we end up with 37.5% of the original light. How is this light oriented now? Same as the filter. Exactly right. We could continue and add more and more filters if we wanted and just use this equation over and over again. So polarization, we actually have polarization to some extent whether we want to or not. If you're buying a pair of sunglasses and you ever want to know if they're polarized or not, you can take them, look at a reflection of, say, the lights off the floor, and turn them. The reflection should dim as you turn the glasses. I don't know if you guys want to play with these. So basically, polarization, it's nice in terms of being able to reduce glare off of different objects. Some The little LCD screens on your cameras and whatnot, some of those are polarized. If you're wearing polarizing sunglasses and trying to look at your camera, sometimes you can't see the screen. Or your phone. Kind of throws people off at first. Because you're worried that your phone or your camera isn't working correctly. Then you take the sunglasses off and it works just fine.